somebody came up with the bright idea of having one of us take another one of us, like somebody volunteers some code and somebody else refactor it. And Nick volunteered the code and I volunteered to refactor whatever Nick gave me. So what Nick gave me was a solution that he had come up with to this.
Nope, your solution to this.
He come up with a solution to airplay doing that.
Yes.
All right, nobody else use Wi-Fi. So it's this code jam problem called Deceitful War. And the idea is there's Naomi and Ken play this game. They have these, the way it's formulated is they have these blocks of different weights or masses, and they play a game, they play war with it where Naomi picks, so both Ken and Naomi weigh their blocks, so they each know how much their blocks weigh, but they don't know what the other blocks weigh. And then Naomi picks a block and tells Ken what it weighs, and then Ken selects a block and tells Naomi what it weighs, or they put it out in scale actually, and whichever one's heavier wins. I can't find anything that makes that actually different than just playing war with cards. Like it seems like just a strange way to formulate it. So as far as I know, we can pretend it's just played with cards. The problem though is there's an imbalance because Ken gets to know what Naomi's playing and use that to select his card. So a strategy for that is to select the smallest card that beats Naomi. And Naomi figures this out and figures out that that's why she's always losing. So she comes up with a way to cheat, which is the way the way this is set up is she, without Ken knowing, she weighs Ken's blocks also, which is basically equivalent to just looking at Ken's hand and playing war with cards. And so now she'll say that she's going to play a card, and then Ken will play a card, and then Naomi will select a different card based or something like that. So, and the idea was to model that and model both of Naomi's strategies.
Does Naomi know the mass of the block that Ken chooses? Or is it?
When she's cheating, yes.
I mean, after he chooses it. It doesn't say that in the...
Well, the thing is when she doesn't know the problem is she knows it too late because she's already chosen a block that she's going to play when she's playing honestly.
But when he picks his, does she know the mass of it? Does he have to announce it?
No.
It says they put it on a balance.
Yeah, it doesn't really matter. If he does announce it, it doesn't change anything because she's already selected her block. But when she's being deceitful, she knows the weight of the block that Ken selects and then selects a different block than she said she was going to play.
Or another way to put it is, since she knows the range of weights, masses of Ken's blocks, if Ken is playing optimally against her, she could make a very good educated guess as to which block he's going to pick based off of the block mass she says she's going to use.
So anyway, the cool thing about the code that Nick handed me is that it's got tests. So I was able to just refactor it by just refactoring because I've got test coverage.
So they were correct tests?
Yeah.
All right, excellent.
Ish.
Just ish.
Yep. So I set it up so I can have guard running. Oops. Okay. So, and this is where most of the code is. Basically, the code is here and over here with Naomi. So she's got her normal strategy and then her sequel strategy. So right away, we look at this code and we can see that in Deceitful War, we've got results and deceitful results. And these two methods are almost entirely identical. The only difference is how Naomi turn here gets, the value that Naomi turn gets, either uses turn or deceitful turn. So right away, we can refactor that away by just abstracting over a thing that's different right here. Now, this calculates the score by going through all the turns and getting Naomi's turn each time. So it's actually not a value we're abstracting over, it's a behavior, so we can use a block instead of just a value. But we can find a method down, a private method down here called, I don't know, play game. And basically all we have to do is just copy one of these down and replace the part that's different here with the yield. And then results, we can just say game and turn like that. And everything still works, and then we can make the same change here. And it works, and we've shortened it up, and we've made it really clear. It's really easy to see now that what's inside the braces here is the only thing that's different between these two. All right. So now we can focus on the big, right now, the biggest method left is play game. We can focus on that. One of the things I always notice when I see a method that looks like this, where it sets an initial value and then it goes through a loop, accumulating results into that value and then returns it. That's a common enough pattern that there's a method, there's actually a fairly fundamental operation in programming called a fold, which Ruby pronounces inject. So we can just straightforwardly turn this into an inject. We inject the initial value into a block. Points, and we actually, in this, wait, we need something to inject that into. Right. Okay. And we don't actually. So inject, the block gets the accumulator value and then the thing that it's iterating over, which in this case we don't care about the thing that it's iterating over because it's just a counter that we're ignoring. But here we can just move this code up here and turn this assignment into just a regular addition. And that should work. What do they do?
You can underscore after the comma.
Naomi points underscore.
Really?
Yeah.
Well, the other thing is you're returning nil from that block sometimes. You should return active nil.
Oh, right.
Active nil.
Oh, actually, yeah, let me back up. I forgot, let me do a different refactoring first.
Oh, okay.
Let me just back up. I did this out of order. Let's actually take this thing, this conditional thing in here that's kind of hidden, and just extract that out. And say store turn, and pass in what the Naomi turn is. And then we can say if it's that, and we want Naomi's score to be 1 or otherwise 0. And then we can say score turn. And that works. And in fact, we can just say yield there. We no longer need a temporary because we needed a temporary because we didn't want to calculate it twice in the same loop, but now we're just passing it as we're kind of getting a temporary variable as a parameter. So,
But we're making Ruby do the work for us rather than us doing it ourselves.
yeah. So now we can actually turn this into an inject right away. I'm actually going to use curly braces because this is actually an expression.
you just don't put the comma at all, that would work too. You don't have to take both.
Yeah, but isn't that going to take the 2 parameters and stick them in an array?
I think he's right.
Yeah, because I want to ignore the rows.
Okay.
Yeah, I think so.
And then just that, right?
Yep.
Yes, okay, cool. All right, so that's pretty good, but this is still, if you really look at it, it's really doing 2 different things, and they're kind of intertwined. What it's really doing is, you can see from this, what it's really doing is it's going through scoring all of the turns and then summing them up. So I like to make those separate steps actually explicitly separate in the code. So what we can really do is say number of turns and times at map score turn. And this may look kind of weird because I'm mapping and I don't have a block argument, but again, it's because I don't care about the value. I just care about the number of things that I'm mapping over. And then I can just do the inject at the end to sum those up. Cool, and now this is turned into a bunch of one-line methods, which is pretty cool. A couple of things I don't like about this, and one of the first things that I can see that I don't like about this is these 2 methods results and deceitful results. So this deceitful war class is sort of given the responsibility of determining how Naomi's going to play. And it seems to me that really should be Naomi's responsibility. So what we really need here is an honest Naomi and a deceitful Naomi. And we want this, and we can pass either honest or deceitful version into this method, and then we just have 1 results. Problem is the spec is set up to assume, the spec is not set up to work that way. So we need to do some refactoring of this.
There's one issue with that, isn't there, in that deceitful needs to know the blocks, right? Ken's blocks.
Well, in Ruby, you can do that
Yes.
if you want to.
Well, we're
Be
passing.
deceitful.
Let's just
Yeah,
say
so
Naomi always
for
knows.
deceitful turn here, we're passing in Ken's blocks.
Right.
So
Okay.
we can pass Ken's blocks in no matter what, and the honest Naomi can just ignore it.
Well, it just seems like that's a lot of temptation for honest.
Deceitful Naomi.
It doesn't matter how much temptation there is, she's honest.
I think deceitful Naomi should have to browse the call stack and
Oh, that would be
Maybe we can do that refactoring at a hag night when I have 3 hours to
Exactly.
It would also be good if we could allow either Ken or Naomi to be deceitful, right?
Yeah, but the idea was kind of that it was already unfairly biased towards Ken, and so Naomi's deceitfully biasing it towards her. So it's unfair no matter what. So let's do some refactoring here. So let's see, how do we want to do this? So first off, let me create some lets up here. Let me do a let. We start by doing a let for Naomi that says Naomi.new, and then it's going to just take Naomi's blocks, and then same for Ken.
Probably Ken's box there.
Oh, yeah, Ken's blocks. Thank you. Naomi's blocks. And that should have no effect, but now we should be able to say, change this to Naomi's blocks. Make that just the array, and it should still work the same. Same thing with Ken's blocks. And I know it's probably not obvious why I'm doing this. Well, I guess I can explain it. Basically, what I want to get to is each test, instead of setting up like all of the class structure, it's setting up, these are the blocks. I want to say these are the blocks, and these are the results that I get when Naomi's being honest, and these are the results I get when Naomi's being deceitful. But I don't want to say in each test how I'm doing that. So I'm going to start by, I'm starting with the blocks. And let's see. Okay, so made this test a little bit more flexible. Now I basically want to do something similar for the results. So I want to create a let up here that says let normal results. And for now I'll just say that's subject of results, and that SQL results, subject SQL results. Now I should just do replace those. Okay, so now my test is in a, basically, so what I've done here, another way of saying what I've done here is I've basically isolated all of the information about how the game is actually set up and how it operates to these 4 lines. So I can now change the structure of this code that I'm testing, and I only have to change these lines to match. So first thing I want to do is really I want to create 2 subclasses of Naomi, honest Naomi and deceitful Naomi. Honest Naomi. So that's Naomi and deceitful Naomi. To this day, I haven't figured out why sometimes Sublime, when I type in, it outdents and again, and sometimes it doesn't.
Yeah.
Still haven't figured out where the cases are that it doesn't work. Okay, and then we just need to take this down here, and this down here. And now this is, that's close, but the interfaces aren't the same. I need to call both of these turn, and I need to and they both have to take an argument. And then here, how I did this. So actually, I need honest Naomi get rid of this subject. What we really need is normal game is a honest Naomi Ken, and then a deceitful game. Deceitful Naomi Ken, and then normal results is just normal game, not results, and deceitful results is deceitful game, not results. And I don't know if I got everything. Let's see. Oh, right, I didn't actually change this. Yeah, so we could just make this results. That. I need to be passing in the can blocks to these.
The game already has can, you don't need to do that.
Oh.
You just need to call down results.
You're saying deceitful.
Oh, yeah.
Don't say deceitful.
Right. Okay, there we go.
Yay.
Well, okay, cool. So Naomi has gotten simpler, well, broken up. And the deceitful war now has gotten really simple. And there's, in fact, this is the only conditional in there.
Yeah.
So we're doing on time. So that's actually about as far as I practiced. I didn't actually, the last thing that I would look to refactor is this actual block here, this block of code here. And in the interest of Jeremy drinking, I think I'll stop for questions. Questions, comments?
I have a question.
Yeah.
In your test,
Uh-huh.
was it in the test? No, it was in the deceitful war class.
Uh-huh.
Where you defined the play game, why did you use a block as opposed to just passing an argument to that?
Because it has to be calculated over and over again.
It's not static.
Yeah. So one thing you have to understand, one thing you need to know is turn mutates it shifts stuff off a block. So I have to call turn exactly once for each turn.
Right. Cool.
So if I passed it in, I would be calling it just once for
Right.
the whole game. So that's why I needed a block. Although I don't need a block now, actually.
Well, you don't need play game anymore.
Yeah.
You can simply
Yeah,
move.
you can
Play game,
move,
you can move
what's
the-
in the block to yield and move that all the way back up to results.
Yeah.
Now that it's all one-liners.
Yeah. So I could
Yep.
do. That, and then just call that results.
Yep.
And it's even shorter. But now this one liner is kind of spanning two lines, and I would probably score turns as this. Score turns.
Yeah.
There.
I feel like I would want to rename a lot of these methods, like results should probably be something like calculate Naomi's score or something like that. But I know that doesn't make for a very interesting presentation if you just spend 5 minutes reading everything.
Yes, and you have to sort of balance the number of times you rename method and rename variable when you're doing your refactoring, when you're trying to
Yeah.
change structure and show how you can make the code simpler. I think that if you look at the changes made to the behavior is much easier to follow and much simpler now. True, the methods could be a little bit more intention revealing, especially in the public side of things.
Yeah.
But I don't know that I would have done, I would have worked on the deceitful turn one just because it irks me to see it like that. There's at least one local variable there that I don't think needs to be a local variable.
Are you talking about over here?
On deceitful Naomi.
On deceitful Naomi.
Yeah.
Yeah.
Right,
There's like-
there's two things there that, I mean, just needs to be fixed.
Yeah. Yeah, like one of the things, this is like one of my pet peeves in both Ruby and Scala is when people take a collection and then they filter it and then only ever use the first value.
Right.
So that's called find.
Yes.
So we can do, say, smallest block here, and say find, and then say if smallest block.
Oh, she's being completely deceitful.
Yes.
Yes.
She's returning a totally invalid weight. She's just taking the weight. Yeah, that's weird.
Hmm.
If you look at the first branch of the else, she's just making up a weight based on other Ken's blocks, and then she returns that. Wow.
Yeah, and then,
Seems like.
and then you were probably saying this turn doesn't need to be there.
Yeah.
Yeah, turn doesn't need to be there, and
Well-
you're in a weird place where I think that I would probably private methodize smallest block just because it's a concept, not a value to be used in that method. I think you were still returning turn, not just returning
I
no.
don't know.
Well, the problem is you shift it.
Yeah,
You
you-
shift
you
and then do last, whereas before you did last and then
Oh,
shift.
yeah.
Oh, right. Oh, crap. No.
Isn't there like a pop or something that you want to use?
Later, anyway.
Yeah.
Something like, they're, yeah, they have methods for that.
Anyway, about out of time.